All right, welcome Math 10C students. Today's lesson is on 6.2, which is slopes of parallel and perpendicular lines. So you've looked at parallel and perpendicular lines in previous courses. I feel like before we can even start with the lesson, it's really important to remember the definitions of both of those words. So the first thing I'm going to have you do is just write down the definition for parallel and perpendicular. So let's start with parallel. Okay, so a parallel lines, are two lines in the same plane. So again, when we're talking about this, we're thinking of a 2D, not a 3D image. So in the same plane, which never intersect. Okay, so we'll look at an example of both of those, but again, we're looking at two lines in the same plane which never intersect. So you can see that that image there to the left of this definition are two parallel lines, and we'll look at how they are parallel. The next definition that we should know is perpendicular. So perpendicular lines are two lines that intersect at right, in other words, 90-degree angles. Okay, so you should know both of those definitions. I would suggest that you make sure that you write those down in your notes, whether you've printed these note pages or whether you're writing them on separate paper. That's a really important place to start. So we can use the slope to find out whether lines are parallel or perpendicular. I'm going to show you a couple formulas today. Both of those formulas will be found on your formula sheet as well, but we're going to look at those as we go through the notes. So if we were to calculate the slope of both of these lines, again, we could use these 2 points, so point A and point B. So if we take a look at this, remember slope is our rise over our run. So that's a rise of 6 and a run of -3. So we end up with -2 as our slope. If we were to do the slope of the line CD, again, our rise would be 4, our run would be -2. We end up with 4 over -2, which again gives us that same final answer of -2. So these two lines have the same slope. That means these two lines are parallel. Okay, so this rule that we can kind of get from here is that parallel lines will have the same slope. Okay, so parallel lines have the same slope. On your formula sheet, it's written a little bit differently, but it means the same thing. So what it says on your formula sheet is that M, and then it shows two parallel lines, is equal to the M of the original, remembering that M stands for slope. So the slope of a parallel line is equal to the same slope as that original line. Okay, so that means all that's saying basically is that parallel lines have the same slope. All right, let's take a look at this example below, and let's figure out which of these lines are parallel. So they've given us 3 lines with some different ordered pairs and coordinates there, and they want to know if the lines are parallel. So always first, I would suggest taking a look at the picture, okay? When we look at them, they all appear to be parallel, but the way that we can check to see which ones are parallel is going to be by doing the slope of each of the lines. So let's do those slope calculations. Remember, slope equals rise over run. So let's start with EF. Okay, if we count it out to go from E to F, our rise is 1, 2, 3, 4, 5, 6. Our run is 1, 2, 3, 4, and that's to the right, so it's a positive. So we end up with 6 over 4. We can make that even smaller, making that into 3 over 2. Let's take a look now at line PQ. Okay, our rise is 1, 2, 3, 4, 5, 6, 7, 8. Our run is 1, 2, 3, 4, 5. And that is in lowest terms. Let's take a look now at line R. S. So our rise is 1, 2, 3, 4, 5, 6. Our run is 1, 2, 3, 4, 4. So we end up with 3 over 2 in lowest terms. So if we take a look at the slopes of all of them, there are two that have the same slope, EF and RS. So we can say that line EF and line RS are parallel. Okay, PQ is not. So that was a little bit of a tricky one because just by eyeballing it, it almost did look like it's parallel. So we always have to find the slope to check which ones are parallel. Okay, that's kind of the trick, is check the slope. If the slope is the same, then that means that those two lines are parallel. So I would suggest now that you pause the video. On the next page, underneath the example that I showed you there are some questions for you to do. So I'd like you to try out those questions. Okay, so number 1, you're going to circle which ones given the slope are parallel. And for number 2, you're going to have to graph those lines. So plot those points, connect the two lines. You're going to connect A, B, C, D, and E, F. Kind of eyeball it and figure out, do you think they're parallel? And then you're going to do slope calculations to check, okay? So that's what you're going to do to check. The answer key is on the Google Classroom. So if you want to pause the video now and do the check questions at the bottom of page 325, and then I will go on to the next example. So taking a look at the next example, we just looked at lines that were parallel. Now we're going to be looking at perpendicular lines. So remember, perpendicular lines are ones that intersect at right or 90-degree angles. So taking a look at this picture, it looks like PQ and RS are perpendicular. We can eyeball it to start, and then how we check our work is by finding the slope of each of those lines. So I know the work is already done there for you, but we'll just take a look here. So line PQ, again, you'll take a look. We have a rise of 6 over a run of 3, so we end up with 2 for our slope. For line RS, we have a rise of 2 and a run of -4. So we end up with -1/2 in lowest terms. Now, if we were to multiply 2 times -1/2, we would end up with -1 as an answer. So these two numbers here, 2 and -1/2, these are something called negative reciprocals. We've looked at reciprocals before. Now these ones are called negative reciprocals because one of them has to be negative and one of them has to be positive. And when we multiply those two reciprocals together, instead of getting a positive one like we normally would, we're going to get a negative one. Okay, so two numbers that are negative reciprocals, we're going to know that they're negative reciprocals when their product is -1. Okay, so hopefully that makes sense. So that means that -1/2 is the negative reciprocal of 2. So here's kind of the rule for these perpendicular lines. Now it says, sorry, it says oblique perpendicular lines. These are ones that are not horizontal or vertical, but any other kind of direction. So the slope of these two oblique perpendicular lines are negative reciprocals. Remember, the slope of perpendicular lines are negative reciprocals. So that means that a line with a slope of m, whatever that number happens to be, is perpendicular to a line with a slope of -1 over m, in which case m cannot equal 0. Okay, and this is also, again, found on the formula sheet. So even if we were in class and these exams were secured, you would still have that formula there for you. So it's not one that you have to memorize yet. It will be one that you'll be looking at again next year. But at this point, it's one that is given to you, so it's not one that you need to memorize. So let's take a look at the next example and see if we can work through the question here. So this one says, they give us line PQ, line RS, and line TU. And then it's asking if our lines are perpendicular. So you'd start by graphing the lines. They've already done that for us. Now, again, by looking, we look at this picture, it's kind of hard to tell exactly which ones are perpendicular. So it looks like they both could possibly be. So what we're going to do is we're going to find the slope of each of them. Now, since they've given us ordered pairs above, we can actually just use those ordered pairs to find the slope of each of those lines. So if you remember, slope can also be equal to y2 minus y1 divided by x2 minus x1. So let's do the slopes for each of these. For line PQ, okay, we have 8 minus -1 over 2 minus -1. That ends up as 9 over 3. And we can further simplify that to equal 3. Okay, so that's the slope of that line. Let's look at RS. RS, for our calculation here, we have -1 minus -3 divided by 0 minus 6. We end up with 2 over -6, which is -1/3. And for our last one, TU or UT, doesn't matter. For our points, we have 1 minus 6 over 2 minus 4. We end up with -5 over -2, which is 5 over 2, the negative and negative. Positive. So if we take a look at each of these lines, we're looking for, remember, negative reciprocals. Okay, so we're looking for negative reciprocals. So which of these numbers are negative reciprocals? Well, this one doesn't look the same as the other one, so I know for sure that one is not our correct answer. We look at 3 and then -1 over 3. Well, remember, 3 is the same thing as 3 over 1. That is definitely a reciprocal, and this one's a positive, that one's a negative. So these two are our perpendicular lines. So PQ and RS are our reciprocal lines, okay? Because those are negative reciprocals. All right, so on the next page is the check questions. So that's on page 328. I would suggest that you pause the video now, take a look at those questions on page 328. Again, you're going to have to be doing some graphing, and then you can check your answers using the key posted on the Google Classroom. In the meantime, I'm going to go on to example number 3, which is our last example here. So this is using slopes to identify different types of polygons. So this first one says, is quadrilateral BCDE a trapezoid? So a trapezoid is a shape that has a set of parallel lines. So let's take a look to see if any of these lines in the diagram are parallel. All right, so if we look at DE and BC, those lines are definitely not parallel. EB and DC possibly could be, though. So let's check to see if they are. We're going to find the slope of each of these lines. So remember, rise over run. All right, so we're going to use the slope to check. So if we look at line EB, okay, our rise is 1. Our run is 1, 2, a positive 2. Okay, and let's take a look at DC. So DC, our rise is 1, 2, 3. And our run is 1, 2, 3, 4, 5, 6, which in lowest terms is 1/2. So are these two lines parallel? Well, their slopes are the same. So that means that EB and BC are parallel. So yes, this is a trapezoid because it has one pair of parallel lines. Okay, so the next question below is asking you to figure out if ABC is a right triangle Remember, right triangle means there's going to be a right angle intersect, so you're going to see if there are any perpendicular lines in the triangle below. Once you finish that check question, you can go on to complete the practice. That's page 330 all the way to 332. Again, I always suggest that you do these practice questions. It lets you practice and maybe make a couple mistakes before the actual assessments come up. The 5.7 to 6.3 assessment will be coming up later this week. So please make sure you're doing those practice questions and then checking your answers when you are complete. Hope you have a great day. Bye-bye.